Thank you. Yes, my name is Matthew Bonnick. I am a cloud architect with a company in North Carolina, America called Defiance Digital. We are effectively a fractional DevOps and AWS architecture firm for small businesses and startups. I am an AWS DevTools hero, a co-author of the CDK book. I have an advanced CDK course, and most of my stuff is now on .com. I'm going to move pretty fast today because I got a lot to talk about. I apologize if the accent plus a lot of caffeine has made anything I say blurry. Any slide that I think is useful, I put a little camera icon in the lower right. So if you're the kind of person who likes to take screenshots, phone pictures, whatever, look for that. So we're going to talk about some basics, project layout, stacks, apps, constructs, how to work with external data, single language benefits of the CDK, testing, which is my favorite subject, and then if we have some time, some Q&A again. As a backdrop to the whole thing, we're going to talk about this within the context of building a basic multi-region ECS-based website. This doesn't really exist. It used to run on an actual website called reinvent.matthewbonnick.com, but this isn't reinvent. So there's also a little bit of a media transcoder in there just for some extra flavor. So some basics real quick to start us off. Every CDK application starts off with apps, which has sometimes stages. There are always stacks, there are always constructs, and then when you're done building out all of these things, you synthesize this into CloudFormation code. In the case of our example here, the entire thing is a single application. Each half of it that gets deployed to a region is considered a stage. And then within that stage, there are multiple stacks. We have a stack that represents the website-based information. We have a stack that has just the DynamoDB database tables. We've got a stack that has a media transcoder. And then within that stack, there's a custom construct that I built that handles the actual media transcoding aspect of the application. When this is all done and built and I have everything defined, I go ahead and run a synthesize routine that turns that CDK code in CloudFormation code. And in fact, it's going to turn into a lot of CloudFormation code, potentially multiple files and thousands and thousands of files. But now to get started building this thing, I'm going to use something called Progen. Has anyone in the room, raise a hand, ever heard of Progen before? Okay, a few people. That's better than I expected. Progen is like the CDK, but whereas you take constructs and you turn that into CloudFormation code with the CDK, Progen takes constructs that you build and it turns them into files within a repository. So if you have common configuration files like GitHub Actions or ESLint files or things like that that have to reside within your repository, Progen can make managing those things a lot easier, especially if you're talking about trying to do this across the entire organization where you want the same thing in all of your projects. Based on the community survey I ran last year, not a lot of people know about Progen, which I think is a shame. It's actually one of the cooler projects that has come out of the CDK. And I all suggest you take a look at it. To start a new project with Progen, I just use Progen. I use npx executed because they do pretty frequent updates on it, so I don't worry about a static install. I just use npx and I say I want a new project. In this case, I want an AWS CDK app in TypeScript. You can actually create non-CDK based applications with Progen. You can create it if you want to. This just happens to be the way that I start them off. Now, project layout, I'm actually going to breeze past. How you organize your files within your CDK project doesn't really matter all that much to the CDK. It's largely, does it make sense to you, your organization, and your teams? I tend to put everything in a source directory. This is part of the project layout. Applications go in the source directory. Any constructs that I build, their custom constructs will go in their own directory, stages in their own directory, and then stacks in their own directory. Now, if that doesn't work for you, you can go ahead and again do any sort of thing you want to. Sometimes also put things into the stacks directory and divide them out by basically application tiers. So if I have backend application, then I put all my backend stacks in that directory and so on and so forth. But again, it doesn't really matter. It's how we want to. Let's talk about stacks real quick. There's basically two approaches when you're defining your stacks. You can either go with a single stack or you can go with multi-stacks. With the single stack, the advantage to this is that you don't have to worry about any cross-stack dependencies. And cross-stack dependencies can be a big pain in the butt dealing with in CloudFormation and CDK. The other pro is you get atomic updates. So if you update your stack, you know that everything in that stack was either updated or something failed and everything rolled back to a previous state. The downside to it, though, is you can run into resource limits, especially when you're talking about the CDK where things get abstracted and you get a lot of resources for one construct. you could very easily run into that limit of how many resources you can have in a single cloud permission stack. Updates take longer because you've got more to deal with. Doing these sort of stack diffs to see exactly what's going to change, those things can take longer. They can get really noisy, hard to read. And then finally, you have this thing called atomic blocks, where you've got this big fat application in a stack, and you have to change one little part of it. But this thing over here is failing to update. A good example of this is you've got a bucket policy or something, and an ARM that's in that bucket policy is no longer valid. You try to update that bucket policy and it fails. And the message is going to come back and it's going to say, well, you don't have a valid bucket policy. You go, no, I double checked the code that I just changed 100 times and it's fine. And it's not working. It's going to take you a while to figure out debug. But while that's happening, you can't change anything else in your stack. And that's what I call the atomic block. It's a big pain in the butt. So I tend to go with multi-stacks with all of my applications. I divide things up pretty granular, typically along the lines of state boundaries. So like things like an RDS database will go in its own stack. Buckets will go in its own stack. Those things I really, really want to be careful about touching because they could bring an outage. I tend to isolate them. The benefits for this is I don't have to ever worry about resource limits being hit because my stacks tend to be pretty small. And because of that, I get faster updates, cleaner stack diffs. I also don't run into these atomic blocks. Downside to it, though, is that I do have to deal with some cross-stack dependencies, and that could be a pain sometimes. And if I have a lot of updates, I have to coordinate this across a lot of stacks. And if one stack updated, another stack didn't update, maybe my application is in a weird state. But if you build things to be loosely coupled, that usually isn't too much of a problem. All right, moving on to apps. We all talk about sort of the default app of the CDK, but you can actually build additional applications into your code base. This is useful for things like, well, I want to deploy everything through a GitHub action. And to make that work, I have to have an OIDC provider and a role defined within my AWS account for AWS or GitHub Actions to communicate. This isn't code that I can have in my default app because my default app is the thing I'm trying to deploy. So I'll create a secondary application, and Project makes it really easy to go ahead and define the secondary application. In this case, I'm going to create what's effectively like a Node.js script that just sits there and runs a slightly different CDK CLI command with that -a. And that -a says, I want to run a different app. And I define that app as just a command line utility to run to generate out my CDK code. In this case, I'm just running TS node and hand it over the various things. And then when it comes time to actually running this, it's just as simple as just saying npm run and then CDK GitHub sync. Just like the normal CDK command, just a little bit slightly different syntax. And I can have all the apps I want to for secondary or tertiary. All right, so moving on to constructs. This is probably one of the, in my opinion, the least hit on aspects. Most people I see writing CDK code never write their own constructs. And this is actually a very bad thing. We're meant to be written by you as you're writing your CDK application. The entire intention with the CDK was to make it so that you could logically define your application by creating these things, creating these constructs. Constructs are supposed to be modeling your business functionality and not necessarily just being resource encapsulation. So you should be saying things like, I create a construct as my ingestion construct or my media transcoder or my X or my Y or whatever that is specific to my business problem. That means that you should be creating a lot of these things in most cases. They should be fairly discrete, very purpose-built. And I suggest you do this from the start because as you create constructs, you are effectively changing the CloudFormation logical IDs that will be generated. And if you change a logical ID, CloudFormation sees that as a drop and a recreate. So refactoring after the fact can be very, very painful. And then finally, your constructs and your stacks should be environment agnostic. They shouldn't care whether they are being used for development environment, creation, or production. So you should never see properties like is dev or is prod in your properties, the constructs and stacks that you create. It's a little bit more okay if you're doing this in a stage, but definitely not within a construct. All right, so this is the code for the video transcoder stack. And as you can see here, there's a ton of stuff going on here. And this is a very simple bit of my application code. This is basically two things. And you can see there's still a lot of code defined. So the first thing I do when I see stuff like this, I have in this case 137-ish lines of code, is I start separating that out into different constructs. So I boiled this down into what was effectively there. There's the transcoder construct itself, and then I've got a way of testing that transcoder. So this is now my stack definition. I want to see what's in my stack. It's a lot more clear now what is in it. And if I drill into these individual constructs, I have my transcoder construct, so I know that everything in here is related to that transcoder, only the transcoding process of videos and things like that. And then if I look at the testing construct, I can see this is just used for testing things. If someday someone comes to me and goes, oh, the test fails, I know exactly where to go in my code to find out how that works. We'll get more into testing here. So external data. If you work with the CDK long enough, you're eventually going to ask yourself, I've got data in this other system. Why can't I use that to drive my CDK code in some way? So for example, after I got this thing built, one of my teammates came to me and they said, well, we want to build a system that also has access to the underlying S3 bucket or has access to some other parts of the system. So we need a service account, something that gives us access keys to read those resources. Now, I don't want to go and just kind of manually do this because I may be supporting a team of dozens of people. They may need hundreds of service accounts over time. So instead, I give them access to a DynamoDB table through a fancy UI or just through the console. And they can go and put in those service account details they need to in there. And I want to drive that to have IAM users created through CDK code. Now, the first time I ever did this, I did something like this right here. I have a API call that goes over to DynamoDB and retrieves out some information from it. And then once I get that information, I go and instantiate a stack with that information. And then the whole thing gets synthesized from there. And this is actually really, really bad because one, it obfuscates your inputs. You never get to see what that data is that came out of the API call and drove your CDK code. And in this case, it was handling IAM users. That is an extremely risky thing to all of a sudden potentially change, delete, or otherwise you could bring down system access. And you never get to see that input one way or another. It's just magically passed through the system. This can lead to a lot of non-determinism, and you want deterministic IAC code. It's absolutely fundamental. IAC code be deterministic. Every single time you run it, you should be able to get the same outputs as from the same. And if you don't do all this, eventually the whole thing is going to explode on you and cause you a really, really bad day. So we're going to change this around just a little bit. I'm going to still have that same API call from before. But instead of handing it directly over to the CDK code, I'm going to drop it into a JSON file in my repository. In this case, just data.json. And then I go to my CDK code. Well, sorry, first I go to Progen and I write in a little script that makes it very easy for me to execute this script code to remake the API calls. And then within my CDK code, I read that JSON file and then I pass that to the CDK code. So I've introduced one little level of indirection, if you will. Rather than going straight to the API call, I make it two steps. Get the data from the API, write it to a JSON file, and take that JSON file and hand it over to the CDK. And the benefits of this is that one, it actually replicates how context in the CDK effectively works today. Context is used for any time the CDK has to be able to go into your AWS account and get information out of that account to then hand over resource definitions and other things. It also makes your code a lot more deterministic, and that's why the context does this. Your inputs then are visible within your repository. If there's any changes to them, then it's obvious as soon as you do a PR, as soon as you're doing any code reviews, and it isn't going to change unless you tell it to change. So no more magic inputs and outputs. One of the reasons why I got really into the CDK was because I was a JavaScript and TypeScript developer, former C# developer. I really liked being able to write my IAC in the same language, but it wasn't just a convenience of not having the context switch between languages. There's also the benefit that now your code can intermingle a little bit. So this is my Meteor transcoder. It's really simple. There's a bucket, and objects get put into the bucket in the uploads prefix. And an event bridge rule goes ahead and notifies the Lambda to execute. And the Lambda function goes over to the media convert service and says, please go convert this MP4 file that was just dropped into this bucket. Part of that service definition and that API call to do the conversion is I have to give it an IAM role to use for accessing that bucket and reading and writing the objects to it. Now, in my CDK code, I'm going to probably have something like this. I've got my Lambda function, I have an environment variable, and the environment variable defines that role that's going to be handed over to media convert. And then within my Lambda handler, I read off of the environment variables that RNG use, and that gets passed through to the API call. If you look really carefully, there's a bug in this code right now. Anyone see it? Anyone? Raise your hand if you see it. Okay, so this is perfect. It's a really subtle bug, and it's something that you will miss every single time on PR reviews. This environment variable has the word R in it. The environment variable I set in my CDK code does not, which means my Lambda handler at execution time is going to get undefined. And that's going to be something that you won't know until runtime, and you won't be able to debug it terribly easily. You're just going to sit there and go, why did this thing fail? So what I can do is I can go back into my Lambda handler. I'm going to define a constant. I'm going to export that constant so it can be available outside of that file. And it's just a constant that has the word media convert role arm. That over in green text, that could be anything I want to. At this point, it doesn't matter. My Lambda handler code is going to reference that constant when reading the environment variable, and my CDK code is going to reference that constant when writing it. So they cannot be different. It's going to save me a lot of time with minor kind of typo errors that your eyes just aren't really good at picking. This is just one simple example. Data models, interfaces, these other things, for example, DynamoDB tables where you have your primary or partition key and your sort key. Those key names and things like that are really easy to hand around through your Lambdas and your CDK code to processes like this. All right, so some do's and don'ts with stacks. I like putting stateful resources in all their own stacks. If it's a stateful resource, something that I want to be very careful about changing or accidentally replacing, I put them in their own stacks, so I don't have to ever worry about accidentally wiping those things out without knowing I'm about to do it. Always when you are creating instances of stacks, always provide the account in the region. Every single instance of a stack that you create should always be for a specific account in the region. That's either done through stages or done through your main application, but you should never be reusing stack instances across multiple accounts. Refactor your code early and often so you don't have to worry about logical IDs changing, and always use snapshot tests for all of your stacks. I'll cover snapshot tests here in a moment. Pretty good on time. Don't let your stacks have more than 7 constructs. This isn't a hard and fast rule, but if you start to see more than about 7 constructs in a stack, you probably need to refactor things. I'm not saying you have to pull them out of that stack and put them into other stacks. Just refactor your constructs, group them together better. There's probably some better organization that you can do to make it all reusable. And again, don't reuse synthesized templates. You should not take a CloudFormation template that has been rendered and synthesized for one account and region and execute it against a different account and region. It'll almost never work well. When it comes to constructs, constructs are supposed to represent business functionality, make them small and discrete. Refactor these things early and often, and when you're writing these things, especially if you're going to do it in libraries for other people to use fine-grained assertions in your tests to verify everything's working the way you want it to. And finally, don't use imports within your constructs. So imports are those things where you already have a resource that exists in AWS that's not being managed by your CDK code, but you need a reference to that object so that you can work with it. So buckets, DynamoDB tables, things like that. You can import those into the CDK. This is where context comes into play. Don't do importing within your constructs. Your constructs should be dealing with concrete objects, not just an ARN or a string that represents it. You can do it in stacks. Do it in stacks all you want. VPCs is a prime example of this. Within your stack, you can import a VPC so you can get references to it. Don't do that in constructs. All right, testing, favorite part. Use snapshot testing for stacks. I'll show that to you here in a moment what that looks like. Fine-grained assertions for your constructs, and then we're going to talk about mocking assets and how that can speed up your test and make for more deterministic tests. So this right here is a pretty simple little bit of code for a snapshot test. This is actually more complex than most snapshot tests that I do. The real key of it right here, though, is that I've got my stack that I create at the top. Sorry, let's go to the screen a little bit. But this right here at the bottom, I use this template class and the helper method from stack. It effectively allows me to render or synthesize the template and then reference it in memory very easily. And I just do a 2.json on it and then do the match snapshot. Just allows for this snapshot concept. The idea is the first time I run this test, whatever the result of that stack is in the JSON format, it just takes as a passing test. It's correct. And then it writes it to a file within my directory. And then the next time I run the test, it compares the new execution of that code versus what was stored in the file. And if they match up character for character, then it's considered a passing test. If there's any difference whatsoever, it considers a failing test. Now, if I am legitimately making changes, I can then use this as a very simple method to see what is changing in my template. I don't have to worry about diffing it against an environment or anything. It just makes it very clear what I actually changed in my code. And once I'm happy and say, yeah, that's about the CloudFormation code that I wanted from this CDK stuff, I run an update command to update those snapshots. It goes back to a passing test in there. And generally, I have a live template within WebStorm for doing this. So all I have to do is start typing out the template name, give it the stack that I want to test, and that's it. So it takes like 5 seconds for me to write a snapshot test on my stacks. And it gives me a really, really good, easy way to know that nothing's drastically changing on me. And when it does, I know exactly what it is that it's changing. When I'm working with these snapshot tests, though, I always have to end up mocking certain aspects. Real quick, who here has ever mocked anything in their lives? Oh, great, fantastic. So I'm going to mock calls to the underlying Node.js or Lambda function asset generation, ECS asset generation as well sometimes. Because every single time you run CDK code, it's going to try to regenerate those assets, and you're going to get things like new S3 object IDs. This overrides that functionality and mocks those calls for generating those objects, and there are 2 benefits to it. One, it stabilizes my S3 object IDs so that it's not changing every single time I run the test and failing the snapshot test. But it also skips all of that code to generate these things, which is especially great if you're ever dealing with Docker images, because it can greatly speed up your testing process and the runtime of your actual test. You don't want your test to take like 20 minutes to run. Everyone hates that. Yeah, so this will greatly speed them up. Plus, you don't have to worry about having Docker runtimes either to build pipelines. So this is the one for image assets, Docker image assets. This is the one that I use for Lambda functions. And I basically have this thing saved off an old Scratch file on my machine, and I'm just constantly pasting it all over the place. I've thought about trying to put it into a library, but I just don't know if it's really worth it. There is also now a third-party library you can install called the Just CDK Snapshot that basically does all that stuff for you, so you don't have to worry about it. It does the same thing as a snapshot test. It just explicitly ignores those particular fields so that they never come up with test. Now, that's for snapshot testing. If you're going to do fine-grained assertions, your tests are going to get written a little bit differently. But fundamentally, they're just going to be much, much more specific about what you're trying to test. So in this case, this goes, again, back to my transcoder here. And I want to test to make sure that the role that I'm going to hand to the media convert service has all the correct assume role permissions in it and things like that. So I'm going to write all these tests, and this is what the tests generally all look like. So I had created a little on line 17 create test template helper method that gets executed for every single test. And it just comes back with that template object I talked about before. And then on that template object, there's this has resource properties method. Now, there's actually a bunch of methods on that class. This is the one that I use most often. And it just simply says the first parameter is the type of object I'm looking for. In this case, we're talking about CloudFormation references here. So I have my CloudFormation type of an IAM role. And then these are the properties that I expect. Now, I'm not defining all of the properties that should be on that role. I'm just saying that that role should match this. So it doesn't require this to define everything, but everything that's in here must exist on that role. So I assume the role policy document has a statement that allows it to be assumed from the media convert service. And if that's not the assume role policy, then this test fails. But regardless of what the rest of the role looks like, if that matches, then the test passes. And then I just write a bunch of other tests that check for the other things like, does the permission set have the read and write permissions it's supposed to? Yes. Integration testing is also very useful in Progen. You can enable this functionality with this experimental integ runner flag on your project. And then writing an integration test looks a lot like writing just a normal CDK app, but instead of synthesizing, at the end, you're going to use this integ test class, and telling it which stacks that you've defined along the way that you want to test. And like just snapshot testing, the first time I run it, it's going to go off and try to compare it against a snapshot. Now, unlike just snapshot testing, this is going to fail the first time it runs because there is no existing snapshot to compare it to. To get that snapshot, I actually have to deploy it to my AWS account. So I'm going to run this integ update command, and it's going to take my my CloudFormation template, and it's going to deploy it out to US East 1, US East 2, and US West 2 just for fun. And if it gets out to all of three of those regions without an error, then it considers that a successful pass, and it's going to take that template now and write it to disk, just like the snapshot testing will do. The next time I run the test, if anything is different, it's going to highlight those differences. It doesn't deploy anything to CDK or to AWS anymore. It just is going to compare that against the snapshot. But what's nice about this versus the snapshot testing with Jest is that this is actually smart enough to understand some of the context within the CloudFormation world versus just snapshot testing, which is just string comparisons. And this, it tells me, oh, you just changed a partition key on a DynamoDB table, which means it's going to get replaced. And that could be a nightmare and very, very problematic. So big red alarms will go off in your integration testing. That's fantastic. Finally, there's the actual end-to-end testing with your application itself. And there's two basic ways you can get this done. One is with the CDK provided triggers module. The other is with a third-party library that I really like called the CDK Intrinsic Validator. We'll talk about the triggers module first. It's really simple. I start off and I create a function, Lambda function. And then that Lambda function is going to be responsible for performing some sort of runtime test against my application. And then down here is this trigger construct. Now, this is just a really fancy wrapper around a custom resource. It's going to go out and it's going to execute my function. I give it a maximum timeout of 10 minutes. And if that function completes without an error, if it completes without throwing an exception, then it's considered a pass. And the stack continues along its way through to completion. If that function throws an exception, errors out, my test does not pass, then that custom resource is considered a failure and it starts the rollback process on my stack, meaning that I roll back to my previously good state and that I know everything is still stable within my account. My actual function here in this case is a really simple fetch against my URL, nothing too fancy here. You can write this thing to be as complicated as you want. Now, this is the CDK Intrinsic Validator. I like it a lot better because it has some basic validation checks that come out of the box. I don't have to write a Lambda function if all I want to do is make sure the website is responding with the 200 code. I just tell it what URL to hit, and it goes out, figures that out for me, writes the code kind of behind the scenes. But let's say I want to go back and I want to test my transcoding, my little media transcoder here. That's not a simple HTTP check. I have to do a little bit more. So what I'm going to do is I'm going to create a state machine. And that step function state machine is going to be given to the intrinsic validator and say, go execute this state machine. If the state machine runs through till completion without an error, then it's considered a passing test. If there is any sort of fault in the state machine and it fails, then it's considered a failure. And everything again rolls back. So what I'm going to do is my step function state machine is going to go drop an object in this bucket and then wait 30 seconds and try to read the converted file out of the bucket. If it doesn't find it after 30 seconds, then it's considered a failure. If it does find it, it's considered a pass. So in the failure state, it goes ahead and just rolls back everything. And I know that my media transcoder is still working every single time I do it. That's a simple example, but really at this point, when you're talking about trying to end-to-end test an application, you could do pretty much anything you want to at this point, within the limitation of the runtime timeouts of a CloudFormation update. You couldn't have a 3-month-long integration test, but you certainly could have a 30-month-long integration test. All right. So we're right at 30 minutes, I think. Yep. So Q&A if it's available, because I know we don't have a speaker after this. Otherwise,
we have the end note to the
we do,
big
yes.
room. Yes.
If you want to have any questions or come ask me anything, that's it. I'll be outside and be fine. Thank you. For sure.